Okay, hello everybody, welcome to physics. We're going to go over a couple of review things for the test tomorrow. First question is, what's the difference between a vector and a scalar? A vector has size and direction, a scalar has just magnitude or direction. Here's a little list of examples. Velocity, what do you think that is? Acceleration, what is that? I'm not hearing many people. What are all these things here? Vectors or scalars? These are all vectors, right? So then scalars would be things like speed, distance, time, temperature. One of the easy things is you always know that scalars never have a negative, where vectors can have positives or negatives. Any questions about that? Okay. So let's get easy 4 points or 4 questions right on the test. What if we do this? What if I take vector A plus vector B? What's my resultant? Vector A plus vector B would be vector C. Do you agree? Okay. So notice these are situated tail to tail, which is kind of a common thing for tests. But we have to add them head to tail. That's why we get that. What if we go A minus B? What would that look like? It would look like this, right? Because A minus B in that direction is going to be the same thing as A plus B in the opposite direction. So don't forget that. You already know that. Okay? So let me ask you this. Let's say that a duck has a max speed or velocity of 10 meters per second. That's like the fastest they can fly without any wind. And they're flying as fast as they can, but there happens to be a 3 meter per second headwind. How fast is the duck actually going to be going? 7 meters per second. Okay? So you can do that, right? Okay. Oops. Well, what if we had a situation like this where we went, 30 meters this way, and then we went 20 meters this way, and then 10 meters this way? How would you solve that problem for the resultant displacement? Why not coming out of geometry, you'd want to go like this and start making a bunch of triangles, but that doesn't work because these pictures are never right. So you just use the X stuff and the Y stuff alone. And in this case, there's only one Y, and it's 20 meters, and it's down, right? And in the other place, we have a 30 meter X plus a 10, which is going to equal 20 in that direction. So then you just have a new triangle, 20, 20, and this would then be our resultants. Can you do that for the test? Okay. So what if we have XY coordinate system, and it has some vectors here. We'll call this A, we'll call this B, we'll call this C, and D, and E. So how many of these vectors have Y components? 4, right? How many have X components? 5. Don't forget this one, that's right on the line, that counts. So there's 5 there. How many have, if you put 2 together, which Y's would almost cancel out? E and D, right? Because this y is up in that direction about that high, this one's in that direction about that low, or, so those would basically cancel each other out, do you agree? Okay. How would you find, if you have theta, how would you find the x component of the A vector? Wouldn't that be cosine theta times the hypotenuse equals the x part of the A vector, okay? And then the y part would be sine theta. So you gonna be able to do that for tomorrow? You can do that, okay? What is the name for an object traveling in two dimensions under the influence of gravity? Projectile motion, right? And the path of a projectile is called what? Its trajectory, right? Okay, does a jet have projectile motion? No, because there's engines, right? Does a baseball have projectile motion? Pretty much. What do we call this shape, like right here? That's the shape of a projectile motion, or that's the trajectory. What do we call that? Parabola. Very good. Okay. Let's take this a little bit further. So let's talk about this. Okay. And I'll have velocity at A, B, C, D, and E. So according to this first initial velocity, what does A have in common with that? Or what's different from A in the first velocity? Well, isn't the x, isn't the x the same here and here? The x velocity is the same. How about the y velocity? It's smaller up here, right? So if I have it here, and here it's going to be smaller. How about up here? What do we have? No y, just x, right? So the velocity at that point is equal to the x velocity in the beginning, because there's no y. How about C? What do we know about C and A? They're not the opposite. The y is the opposite. Very good. So the y is going to be opposite. The x will be the same. So they have the same magnitude but different directions. The y is opposite. How about D? What about D? Right. So it's got the same magnitude of velocity as the initial. The difference is direction. The y will be down instead of up. And then E will have the largest y and continue to have the same x velocity. Looks bigger, but it should be the same. Okay, so you can do that, right? So let's start into the free response portion, which you'll be asked to do tomorrow. Let's just say I have a 5-meter high table, and I'm coming off of it with 15 meters per second. Can you tell me how long it's going to take for this thing to hit the floor? Yeah, right, because you can use this formula, and you can know that the y velocity at this point is going to be 0, right? Because there's just an x, so then x equals 1/2 at squared. T equals the square root of 2x over little g. In this case, the square root of 10 over 10. T equals 1 second. Can you do that for the test? And then after you tell me that, can you tell me where it's going to land? Well, x equals the velocity in the x direction, which does not change, right? Times time. So in this case, it's 15 times 1, 15 meters. Can you do that for the test? Okay, so that's one of the 3 free response questions. Okay. So the next one then is going to be the soccer punts. Okay, so here's the trajectory. The thing we have to use on this one always is v equals 0 here. So let's say that we have a time equal to 10 seconds. In the end, what I'm going to want to know is how far in the x direction will it be. But the first thing that you have to know, and I'll ask you to figure out the vertical velocity, horizontal velocity. I'll ask you to figure out the height, and then finally the distance. Okay. So since this is starting and stopping in the same x-plane, we can use half the time, because we know that'll take us up to the point that's the highest. That's the highest. So we can go v equals v sub naught plus at. We can cancel either one out, it doesn't matter. But negative v sub naught is negative 10 times 5 seconds. So v sub naught equals 50. Can you do that for the test? Yeah, that's part of it. So we got 50 here. Okay. I forgot to put in part of the givens, which I'll give this a 30 degrees. Okay. So now we have to figure out our velocity in the x direction. So tangent of 30 equals 50 over the velocity in the x. So you might be careful on this, because kids a lot of times will just do the multiplication thing because that's what they're so used to doing. But you can see in this case it's not going to happen, because we have our unknown in the denominator. So the velocity in the x then becomes 50 divided by the tangent of 30. And that number is 86.6 meters per second. So the velocity in the x direction is 86.6 times 10 seconds, or 866 meters. Can you do that for the test tomorrow? Okay. So there's really only one other kind of free response. I bet you can guess what it is. It's flying off the edge of the table, and we have a height, say it's 20 meters, and we'll just give this a real easy angle, and we'll call it 100 meters per second. The thing's going to fly. So the first thing you got to do is figure out the x and y velocity. Can you do that? SOHCAHTOA gives me 50 here, right? And 86.6, something like that. Okay, so you can do that. But the question is not that, but the questions are the time up. The next question is going to be the time down. The height up, which would be this piece right here. And then last but not least, how far it goes horizontally with all that time. So the time up, we already know it's going to be 5 seconds, right? Because negative v sub naught divided by a equals c. So I guess we don't need to do that, did we? Because it'd be 50 divided by 10 equals 5 seconds. So we don't want to do that. The height up then, though, we could use x equals v sub naught t plus 1/2 at squared. And you can just zero this out right here, right? Because you know up here, v sub naught equals 0. So then x is 1/2 at squared. X is negative 5 times 25. So x comes out to negative 125. But it's really positive, right? Because we went up here, called that v sub naught. It's actually plus 125. That's how high it is. Can you do that for the test tomorrow? Okay. And then the time down here, well, time down is going to also equal square root of 2x over little g. But the x is from here. So we got the whole height there plus another 20 meters, which is going to be 145 times 2 divided by 10. Take that square root, and we get 5.4 seconds. Can you do that for the test tomorrow? Okay. And then last but not least, x equals velocity in the x direction times time. X equals 86.6 times 5.4. X equals 4. Actually, it's 10.4 because this is total time. So that is going to be equal to 866 times 10.4 is 964 hundredths of a meter. Can you do that for the test? Okay, then you're ready.